Hello and welcome back, everybody. We're going to talk a little bit today about three-dimensional objects. Like I said, we have to cover surface area. We have to cover surface area prisms, surface area of cones, and all that other wonderful stuff. So let's get into it. Surface area pertains to a three-dimensional object. So if we go back and we take a look at all two-dimensional objects, you have things like quadrilaterals or triangles, and you have your circles, you have your trapezoids, all that wonderful stuff, which is another quadrilateral type. But all of these have they have two things. They have a perimeter and they have an area. Now, as far as that goes, the perimeter has always been the distance around. And then the area has always been the quote-unquote stuff inside. And we find, we have different areas. We have the area of a square is side squared. The area of a quadrilateral is length times width, or base times height. The area of a trapezoid is 1/2 base 1 plus base 2 times the height. The area of a triangle is 1/2 base times height. It's kind of fun. The area of a trapezoid is good for any quadrilateral as well as any rectangle. So I actually think that it'd be better if we just stuck with just the area of a trapezoid to make things a little bit more streamlined in that regard. But in any event, but we have these areas. And so with those, you can find, if we had, say, you're given some quadrilateral that is, say, 5 feet by, 7 feet. And you can find the area, and you could say, well, the area is going to be 35 feet. You found that by saying 5 times 7, which was 35. So the distance around would be 10 and then 14, which would be 24. So my perimeter would be 24, but my area would be 35 feet squared. Multiplying foot times foot gives you foot squared. Footses, if you will. And so this is pretty much what we did on two-dimensional levels. Now, in a three-dimensional space, now we don't deal with quadrilaterals, rectangles, triangles, circles, trapezoids, all that stuff. Now we deal with things like rectangular prisms. So we have what looks like a typical rectangle, and we make it into a three-dimensional object, and now we have a rectangular prism. We used to have, it once was a triangle. Now we have now we have a pyramid. So here's your pyramid. So pyramid. What once was a circle, now talking 3 dimensions. Now we're talking about a sphere. So we have a prism, we have a pyramid, we have a sphere, we have cones. Oh, those are fun. Those come in waffle and sugar, and make life just taste a little bit better for dessert time. But we have cones as well. We also have other things like tetrahedrons, which would essentially be something like a...
Ms. Huffines, please come to student services. Ms. Huffines, please come to student services.
If you had say you had a triangle, and then it's, if we were to say, here we go, something like that, that would be more of a tetrahedron. So you have your cone, and then you have your, I believe it's a tetrahedron, it's spelled correctly. I'm just kind of going off it. Okay? Now, there's ways that we can do this. We can figure these out. Okay? With that comes the different types of formulas. So we have the formula for a cylinder. The formula for a cylinder for the surface area is going to be 2b plus LA, B being the area of the base, and LA being my lateral area. And in this case, B is pi r squared, and my lateral area is circumference times height, and circumference is 2 pi r. So, in all actuality, the surface area looks like 2 pi r squared plus 2 pi r times h. Okay? That's a cylinder. The next one. Oh, shoot, you might not have been able to see that at all. So let's move that back down. Let's take a recap look at this. Cylinder, surface area is 2b plus A, or plus LA. Where B is my area of my base, LA is my lateral area. B is pi r squared, LA is circumference times the height, circumference is 2 pi r, so my circumference is 2 pi r squared plus 2 pi r h. Okay? Let's do my cone. The surface area of my cone is actually going to be something sort of similar. Surface area of my cone is going to be pi r squared plus pi r L. Well, what's L? L in this situation is something called a slant height. It's a slant height. So if I were to draw a cone, you know, and it's got something like this, so it's sitting on the ground. This length right here, so from here to here, along the side, physically along the side, the slant side of the cone, that is your slant height. Okay, it's different than your regular height, where your regular height is just, you know, straight down. You know, this is your h, so that's your actual height. If that makes sense. How it's different than your slant height. Okay. Next one is a sphere. A sphere, really simple. Surface area is 4 pi r squared. It is what it is. At this point in time, you just plug it in, chug and go. Make sure you have your radius and not your diameter. Pyramid. Pyramid is kind of like cone in that it has a slant height. So pyramid, the surface area, is going to be B, which is the area of the base. Since there's only one base for the pyramid, we only have 1b, plus 1/2 my perimeter times my slant height. Once again, my P here is my perimeter. And then this is my slant height. So it goes, you know, if I were to draw a pyramid, so I have my little pyramid here. Okay, and once again, this length right here that goes down along this side, this here is my slant height, as opposed to if I were to go straight down to the bottom of the actual pyramid itself into the base, that would be my h. Okay, so we're talking about the slant height, L, and not the height, h. Okay, last little piece that we need is the prism. We did not talk about a prism. Prism is kind of the most basic, and but anyway, the surface area is going to be 2 times the area of the base plus the perimeter times h. Once again, like I said, the P, the perimeter, and then you have your h, which is your height. Okay? So you have your perimeter and you have your height. That's for a prism. Now let's take a look at a prism, and I'm going to look at it in 2 specific ways. The first one, first I'll do is I'll draw my little prism in. you know, this is not an episode of Bob Ross. So, or maybe it is an episode of Bob Ross. You know, it isn't. We're not really trying to be super duper artists here. We're just trying to get a picture of what's going on and just kind of letting things flow and be happy where they are. So I'm just going to throw some numbers in here. We'll call this 10. We'll call this 6, and we'll call the depth 4. Okay? So, first thing I'm going to do is I'm going to say, all right, well, this is a 6-sided figure, so that means all of my depths are 4. So 4, 4, 4, 4. All of my heights are going to be 10. So 10, 10, 10, 10. And then, similarly, all of my widths are going to be 6. So 6, 6, 6, and 6. Okay? So what I can make is I can make what's called a compound area problem. I can turn this into a really, really big two-dimensional object, where essentially I just, to find the surface area, I'm just going to add up the areas of all the other objects. So the first one, if I look at the top and the bottom, it's 4 times 6. So the area of the top is 4 times 6, or 6 times 4, which is 24. The area of the bottom, the little subscript T, subscript B for top and bottom, is also 6 times 4, which is 24. Then I have the area of the right side and the area of the left side. So the area of the right side would be 10 times 4, which is 40, and 10 times 4, which is 40. And then you have the area of the front side and the area of the back side. The area of the front side is 10 times 6, which is 60, and 10 times 6, which is 60. Okay? And then all we have to do is add these together. 40 and 60 make 100. So 40 and 60 make 100. 40 and 60 make 100. That's 200. And then these two make 48. So if I add them all together, my area, my total surface area, is 248 square feet. Or square units, I should say, my mistake. Units squared. Now, I could also do the same thing with the formula. If I say, okay, well, the surface area is 2 times the area of the base. The area of the base is what it sits on, so 6 times 4. So 6 times 4. Plus the perimeter, which is the distance around. So the distance around the object. So 6 plus 4 is 10. Plus 6 plus 4 is 10. So my perimeter is going to be 10 times 2, which is 20. And then finally, my height is going to also be 10, because that's how high the object is. 6 times 4 is 24, times 2 is 48, plus 10 times 20 is 200, and that gives me 248 square units. As you can see, we get the same answer, regardless of how you want to do it. So if you want to take it apart and look at the different objects, great, and then just add them all together. You can do that for the lion's share of them. Obviously, we can't do that for a sphere. But if you want to do it by the equations, then please take time to remember 2b plus ph, as well as cylinder is 2b plus LA. Cone is pi r squared plus pi r L. Sphere is 4 pi r squared. And pyramid is base times 1/2 perimeter times the slant height. I hope this was helpful, folks. I tell you what, I'm going to drop a picture really quick of, you guys can kind of stop this at any time and take a look at it. There are 10 questions on here. Yeah, this guy right here is the slant height. This is the L, even though it's not there correctly, as well as this is the L. And these here are radii. So this is a radius, this is a radius, and that's a radius, of course. So take a moment, freeze it, and when you get all done with it, you can answer these 10 questions. When you come in, we'll see if there's any questions that need to be answered. Thank you so much for your time. Have a wonderful day.